What's up, guys? It's your favorite math teacher here, and today we are talking about dilations. And so dilations is the only transformation where things don't stay congruent, because a dilation is where it changes size, right? So dilation is where it makes the shape bigger or smaller. But as you do this, it still stays proportional. Okay, so dilation is when it gets bigger or smaller. Think about it, if you get your eyes dilated, your pupil gets big and it gets small. And so in a dilation, you have something called a scale factor. So a scale factor is how much bigger or smaller are you making the shape, right? So how much bigger or smaller. And we usually use a variable for this. We use k. So here I have a rectangle, and this rectangle is 2 squares tall and it is 4 squares wide. So let's say that I had a scale factor of 2. Okay, so let's say that k equals 2. That means I am making this twice as big. So it was originally 2 squares tall. Well, 2 times 2 is 4, so now it's going to be 4 squares tall. It was 4 squares wide, so 4 times 2 is 8, so now it's going to be 8 squares wide. And so what happens is it gets twice the size for each measurement. The length and the width are twice the size, right? It went from 2 to 1, 2, 3, 4, and from 4 to 1, 2, 3, 4, 5, 6, 7, 8. It needs to stay proportional. If one side gets twice as big, the other side also needs to be twice as big. Likewise, you can also make it smaller. Maybe I want it to be half the size, so let's say k equals 1/2. That means my scale factor is 1/2, so make it half the size. It was 2 squares tall, so now it's only going to be 1 square tall, and it was 4 squares wide, and so now it's only going to be 2 squares wide. So again, it stays proportional. The rectangles all look the same, but proportionally they're different sizes. One got half the size, and one was twice the size, because that was the scale factor.